Hello, everybody. Welcome to JSS Immersions, Lessons Learned. So I'm Anastasiya Flynn. I'm a front-end technical evangelist with Sitecore. And some of you might be wondering, what the heck is an evangelist? Recently, when I went on a trip to Canada, I was asked if I do something with religion. So an evangelist is somebody who tries to champion the adoption of JavaScript, and in my case, JSS. So I also create a lot of enablement content for developers. So blog posts, videos. I'm here to answer your questions, to pass on your feedbacks to the product team. So try to make JSS as easy as possible for you. I love JavaScript, and that's my passion, and that's what I'm trying to spread. So when I started with Sitecore this past January, it's good now, guys. Thanks. I already knew JavaScript and React and Sitecore, but obviously I needed to learn JSS. So in this session, I will talk about my journey of learning JSS and the third-party modules that I used in my sandbox as I was going through this learning process. I worked with React, and that has over 170 million downloads on NPM in the past year. So with that, that really helps you get started and have a lot of help so that you're not starting from scratch. So one of the primary goals, and this is a quote from Alex Shiba, one of the creators of JSS, one of the primary goals of Sitecore's JSS was to add a proper first-class interface for JavaScript devs and enable using modern JavaScript tech to build websites and web apps powered by Sitecore Experience Platform. So the vision for JSS was to empower JavaScript devs and to not make them dependent on Sitecore. And that's why Helix is not even mentioned in the documentation. That was an intentional choice. We wanted to make JavaScript a first-class citizen and enable front-end devs to drive the information architecture, the project structure, to really make them be able to be in charge of implementation. So as I was learning JSS, I really wanted to test this vision and see is this just talk or is this really possible? So in my sandbox, I didn't create a single Sitecore item. I didn't write a single line of C# code. The sandbox I built was just made in my JSS React project in VS Code. So to get started, I spent about 2 weeks studying the official docs site. And then I watched a couple videos by Rob Earlham, our superstar. There's one on getting started, which is our overarching business value of JSS, and there's another one that takes you through building out your first app. So those are really great resources for anybody getting started. I'll be sharing my deck too, so you guys don't have to worry about taking a lot of pictures. So after that, the documentation takes you through the quick start, which is 4 commands to create your first app, and it launches the app for you in a local Webpack dev server, which is a local server running in your local browser. And this is what it looks like. It has a style guide that shows you pretty much all of the features, all the fields available in JSS. It's kind of like a living documentation of what you can do. And it's kind of all boilerplate, and it's there to help you get started, but it's not needed for actual projects. So I got rid of all that. I removed Bootstrap. I removed the hard-coded navigation. And so we ended up with this beautiful, empty page. So JSS has no out-of-the-box components. There's nothing to drag and drop like some other Sitecore products. So we don't have out of the box, but maybe there's something next to the box. Since with over 170 million downloads in the last year, there must be some open source packages to pull from. So my next steps was to pick a use case from my previous experiences with Sitecore that required a lot of custom JavaScript, which were search pages. So the requirements for my sandbox were the content author had to be able to add event pages. They had to be able to manage them in Sitecore, tag them with different pre-built tags like location and type. And then there had to be a listing page where the content author had to be able to add unique modular components that all responded to search events and communicated with each other, but the author could move them around. So it wasn't just one giant conglomerate thing. So this is what I ended up with. So this is my search page. So when it loads, there's some animation. There's some micro interactions happening on hover. And I wanted a quick view, but I don't like modals. So there's like a flip animation. And the user can filter the events by keywords. And in the upper left, there's a navigation which is pulling dynamically based on the items in the content tree. So, and I'll go into how I built that. Oh, and it's responsive. All right, we get it. So this is an overview of the features we have. A dynamic navigation generated from the content tree, a GraphQL-powered search box and search results. The background is generated, it's a themable background that the content author can customize. And we have two instances of a header component that are rendering differently based on what the content author specified. And I'll show how I built that. So let's get started. So when you first scaffold your application, you're going to see that there's several out-of-the-box commands that come with JSS. So these are powered by scripts, and these scripts do everything from building your app to generating new components to kicking off disconnected mode. And if you ever need to customize what the default functionality does, then you need to go in your package.json file and kind of see where the script for the command is, and then go track it down, and that's how you customize it. So for me, I was looking to customize the scaffold command, so that's there in scaffold component.js. So what I did was, out of the box, this script, it hard codes a specific template for how your default components will look. So I went in there and created two new templates for components. And so now I'm making the default script look for arguments in the command line that the developer is passing in, the process argv.find. And then based on the arguments that the developer is passing in, I can call one of the new templates that I've created. So the normal way is just to say JSS scaffold and then your component name. But here, the customization I've added is JSS scaffold component name, and then I'm passing in a flag for the template type. So I'm saying template equals RFC for React functional component. And then I'm going to build one more for React class component. And I'll show you what they look like side by side. So if you're not happy with what the out-of-the-box components look like, it's a very easy customization to make. Yeah, so here they are side by side, and one is a class and one is a function. So since the scaffolding of a new component creates the files for you, scaffolding also drives the project structure. And it looks like the default structure looks like this. It creates a folder for every component and then a file called index.js. And this is not necessary for React. React, like if you just had components and then underneath it, like navigation.js, search.js, that would be fine. React can handle that. So if this is too much nesting for you and you think it's too much clutter, you don't have to keep this. So you can customize this as well, the default structure. However, the file structure is important because it's used by the component factory, which is the mapping between the React components in your application to your Sitecore components. So if you want to change how your project is structured, then you also have to update your component factory. So this is an example of what the generated component factory looks like. And the component factory is generated by componentfactory.js. It's one of the scripts that comes with your app when you create it with the CLI. And so it's just something to keep in mind that, because see, this is a generated file and it's just looking for, it's finding all of your components. So it's looking for that folder name and that index.js. So that's how it's identifying your components, and then it's adding them by name. And so if it doesn't find those, then, and you have a Sitecore component by that name, then you're going to have errors when you're trying to render stuff. However, I recommend just leaving the default structure as it is, and here's why. So because it's creating a folder for every component, so what you can do is have the index file be the main entry point, and then you can have additional helper files for things like helper functions, or if you're using a CSS in JS library. So for example, my header container has CSS in JS in that background.js file. And then also, since it's only looking for components in the components folder, this makes it easier to add another folder like for shared that isn't included in the component factory for extra utility classes. So everything in shared, card flip, triangle, like that's just used for animations, and that's only used in the React code, and that's not mapped to Sitecore at all, because it doesn't matter for Sitecore. So, so let's move on to data modeling. So I said that JSS empowers JavaScript devs to drive the information architecture. So this is because you can start developing code first, and JSS has a manifest API where the JavaScript devs can define their templates, their items, everything through JavaScript. Now, when you're defining templates in Sitecore, you define all your templates in the same way, and it doesn't matter whether the template ultimately is used for a data source or a page. It starts out a template in the same way. But in JSS, you have to be more explicit about the intent of the template. So there's different functions available for use to express your intent, and this will be important for when the items are later imported into Sitecore. Now, I won't go into too much detail here because I have a very detailed blog post that explains the manifest API, but I just wanted to highlight this as it was part of my learning journey to learn the manifest and how to make these items in Sitecore. But this is very detailed, so please go here to learn more about the manifest API. So next is debugging, because of course this wasn't all a smooth journey. So of course you can have breakpoints when you're working with JavaScript, just like when you're working with C#. You just have to install this extension, the Chrome debugging extension, VS Code, and then you have to add one config file. It's a very small one. And then it's just a matter of running JSS start, and then you just set your breakpoint and hit F5. It's as simple as that. So I'm running JSS start to start my app. And then I'm going to put a breakpoint in one of my event listing page components. And then I'm going to go ahead and go to the event listing page to make the breakpoint hit. And now it's paused, and we can examine the stack trace or the variable values. It's just like debugging C#. So the other very helpful debugging tool is your Chrome React DevTools, and there's an equivalent for Vue and Angular. And this just lets you expand your React tree. And then if you click on any of the components, then it shows you all the props and the values that were passed into it. And of course, the props is what's used to render all your fields and everything. So this is what I use most often. And if all else fails, of course, this console.log. And I pointed this out because you can use console.log debugging not only in your code, but you can stick it into everything in your node folder as well. So for example, if you're getting an error on build, what you can do is just search for the text of the error in VS Code search feature, and you'll find where in the JSS modules in the node folder that error is being triggered, and just put a log statement there. And you don't need to recompile or anything. Just run your app again, and you'll see your log messages heading. So that's very helpful. All right. So let's move on to those next to the box components I mentioned earlier. So websites are made of two types of content: static content and dynamic content. So static content is stuff that, like text and images, stuff that the content author just puts there, and it's there on page load and it stays the same. And dynamic is stuff that changes based on user interactions. So let's see how JSS enables, how JSS works with open source React libraries to make these two things built out faster. So I used this library for building out most of the components on my page. I built it for grid, for my headers, for most of my text. It's called Reactive Rebase. And the reason why it's awesome is because, well, it comes with all of these components, but here's an example of how the components are called. Can you please close that? And so it lets you pass in customizations to the components as props. So if I want to change the font size or the color, I just pass that in as props. So this works perfectly with like something, with a CMS, because we can just expose those props as fields or rendering parameters to the content author, and then we pass them right into our component. So we build one component and then let the content authors drive the variations. We don't need to rebuild it a whole bunch of times. And what's even better is that this library also lets you control the HTML element. So for my headers, this is one component, and the first one is an H1, and the second one is a div, I think. So I have a field called element. I hope you guys can see that. And then the content author is specifying that this should be an H1. So how it looks in back end is, this is my component definition in JSS, and it has a field named element. That's just a single line text. And then this is where I'm specifying what the field values are. So I'm saying it should be an H1. And then in the React component, I'm passing in that value to the rebase library. So, if you've ever been in a situation where you've built out your components and then the SEO expert comes in and makes changes for you, I know that's happened to me, this would solve that problem. These kinds of fields, like the HTML elements field, are what I call invisible fields because you can't expose them for inline editing. So JSS handles that for you by automatically adding a button to the ribbon to edit all fields. So you don't have to worry about that. But if you do want to have your own custom way of doing something in Page Editor, then there's a with Sitecore context helper that comes with JSS, and you can check for page state just like you would do in MVC. All right, let's talk about theming. So theming is like brand colors, fonts and text size, device breakpoints, so anything that controls the look and feel of a site. And I think this is generally applicable for like the big brands that, the big umbrella brands that have multiple sites and they just want to change the skins of their brands. So JSS makes this use case simpler as well. And I used the library style components for this. So this library rocks for the same reason in that it accepts everything as props. So we can have the content author make all the customizations and then we pass them in. And it accepts theme props as the wrapper to your page. So there's the fields coming in and then I'm passing them in and they're on my layout, so they're wrapping everything. And I just have colors here, but you can have, there's so many more options. The documentation goes through everything. And so this is an example of how they're used in a component. So I just have to reference a property from something in my theme. So what this means is that the content author, like if you're using a color throughout all of your components, the content author would just have to change it in one place and it would be reflected everywhere. And this is, I think, my demo of it. So I'm using the color in the header and then in the lines on the search results. So, and this can be used for fonts, for different layouts. All right. And the last library I'm going to talk about is React Spring for animations. It's also very easy to install, and I think this is one of the best animation libraries out there because it's very natural looking and it's very flexible, and they're very up to date on their maintenance and staying up to date with the latest React changes. And of course, it also takes static data as props, so we're seeing a trend here. So I use this to implement the card flip, and so it's taking in one prop for the front of the card and then one prop for the back of the card. So the content author just fills out the front and back separately, and then I'm passing those in. So yeah, here's a wrap up of the frameworks that we went over. So this allowed me to build out my fancy page with all that stuff really quickly. So now let's talk about dynamic content, which I used GraphQL for. Make sure that if you're using GraphQL, that you have the queries enabled in your config. This is a problem that I see a lot of people running into. Like if you see an error, like search is not defined, it's probably because you're missing these in your config. So, all right. So this is the GUI editor for GraphQL called Graphical. And so I'm just going to talk through why GraphQL is awesome as we're going through this demo. So GraphQL is a self-documenting language. And it empowers front-end devs because you're in charge of the query, and you don't have to keep going back to back-end devs to make API changes. So what we're seeing here is that I'm able to, as I'm typing stuff out, I'm getting IntelliSense on the what parameters I have to pass to my query, and then what fields are available on the return. And then for any query I'm using, I can just control-click on it to see documentation for it, which gives me more information about the result types. And then if any of the result fields are complex objects, then I can click into those in the documentation to see information about those objects. So what I've done so far is I've queried for a specific item in the content tree, the root of my sandbox. And I've gotten its name, path, URL, and template. And now I want to get its fields. And I'm specifying that I only want the fields on its particular template and none of its inherited fields. And that's what the own fields argument is for. And I'm saying that I only want the field name and the field value and nothing else. Now, one thing we're not getting is the page title, because that's an inherited field from an ancestor template. So I can query for that field directly by name. So now we have that field name. So you can, just keep layering what you want, and then in the result, it called. It just said field value, but I wasn't happy with what the result looked like. So I changed how the page title was being returned in the result by using a page title alias. So you can even control the shape of your result JSON. So now, in addition to getting a specific item, I'm going to do a search. And I'm referencing the documentation as I'm doing to see what needs to be passed into this query. So it needs a root item, and it needs to know what template to filter on. So I'm going to filter by the event page template. So keep in mind that this is all happening on a single call to the server. So I'm getting a specific page, and I'm doing a search all in one call to the server. So that's a really cool thing about GraphQL. Normally with REST, you would have to do one call for your top level page, then you need to do one call for your search. Then if you want to get details for all the search results, that's additional calls. Here, and you can't control what you get back. It's whatever's built into that method. So, all right, so we're getting our results. So in the first part, we're getting back the specific item, and now our results are also items, so they have the same fields. So it's also name, path, and URL. What we see now is that since the first part of the query and the last part of the query are repeating what they're asking for, we can actually pull that chunk out, and that's called a fragment. So that item part where it's asking for the name, path, and URL, I'm going to pull it out into an item fragment. So that avoids duplication and makes it more manageable, and you can split up if stuff gets really complicated, then you can split your GraphQL queries into multiple files even. So now this is called spreading. I'm spreading the fragment over the results of that item, and just checking that I haven't broken stuff. So now we see that in the results, for my simple fields like my description and my title, my string fields, it's coming up fine. But for my reference fields, my date, my location, which is pointing to another Sitecore item, my image, is just giving me the raw values, which is not very helpful for what I want to stick into my cards. So normally in C#, you would get the field and cast it to an image field or a reference field, and then get the actual values that would be helpful. So we can do the same thing here. So I just clicked on field to get its documentation, and I can see all the implementations of field. So one of the implementations is reference field, so I can just cast field to a reference field. So I can check what's available on reference field, and we have target item, and that's another item. So for that, we'll be able to use our fragment again. So now I'm specifying that for locations fields, we want to use the reference query. So now, when we get the location, we actually have usable data that I can stick directly into my search result card. So, and then, so I do the similar thing for images and tags. So you guys had a whole session on GraphQL, so I'm going to cut this short. And this is an overview of what I went through. So using aliases, using the spread operator to use fragments, and then casting types to do subqueries. Yeah. So to have multiple search components on the page, all talking to each other, but have one context of search results. React has a native, it's called a context API. And so the context is a way to pass data down the component tree without having to manually pass those props down. And the way it works is you define one content provider up at the top of your app, and you can have as many content consumers as you want. And this doesn't affect the performance, because the content consumers are only re-rendered when they need to be, and when the content provider's data changes, and React manages that for you. So the way that this is implemented in my sandbox is if I go all the way to the top root of my application, I have a search container, and then we'll look at the React tree. So the search container is what holds my React context provider. And we can see on the provider, it's what's maintaining the current query and the search results. And so all the components that need to work based on that, they will consume that provider. So here's the code for the search container. So it's just wrapping a global, like a top-level placeholder. And here's the code for that, for the provider that it's using. So it has a state with the count, the query, and the search results, and it's exposing a bunch of global functions which the other components can access. And one of those functions is to execute the search, and that's where my GraphQL query lives, which is the query that we just built out in Graphical. And this repository is available on my GitHub. It's totally open, and you guys can download this. So, yeah. So the other way to work with GraphQL, and this is how I built out my navigation, is to, instead of calling it after page load from your components, to run it on the server. And this is called integrated GraphQL. So here I have the query directly in the component definition, so in the template definition. So so this will run on the server when your page is loading, and what this will do is it will replace the fields property of your component with the results of the query. So we can see here, in my navigation, I'm getting the fields passed in as props, and I could just loop over them and render my navigation. And those would be the results of the GraphQL query. And if you're not working code first, if you're working Sitecore first, this feature is available there as well through this field in Sitecore. So, you don't, if you're not using the manifest API. So we can see via the React console that the fields that are being passed in have the navigation items, and that's how I'm building out the navigation. So that's it for GraphQL. And my final lesson learned, and I know Peter will appreciate this, is to be careful when running JSS deploy and JSS start, because your computer will get hot, which may attract some wild animals. And if you want more JSS immersion, that's my blog where I have more on this topic of my sandbox. And there's the JSS hashtag and my Twitter handle where I post a lot about JSS and JavaScript and occasionally cats. And that's it.
For example, we have a CNBC kind of a client who is having a huge amount of data. In that kind of scenario, if we will use with a search, for example, what would be the impact about the performance? Any idea?
Oh, yeah. GraphQL is intended for that reason. It's supposed to scale really well.
Okay, great.
Yes.
Thanks.
Yes.
In this example, you are searching using one template name, JSS page event. Is it possible I have multiple template to search? Suppose template A, template B, template C, and these cards are any keyword I write, ABC. I need all the items which has been created from template A as well as template B as well as here only the JSS page event, those items are coming in the result. Those items is created from JSS page event template name. So how to pass multiple templates in this query?
I think the out-of-the-box query backend code automatically ands all the things that you pass in that array. So if you look at the implementation for that class, then you can add your own class, which would do an or instead. So remember I showed you the config that you have to include that has the references to the backend classes where those queries are implemented. So look there for where the implementation for search is, and you'll see how to change from an and to an or. Because out of the box is just an and. There's another JSS session after me, so I'm going to stay here for that. But after that, I'll be around for questions.